Welcome to The Explainer. Now, when we talk about AI, we usually focus on the AI itself, right? How smart it is, how fast it can think. But what if the secret to understanding any AI isn't the agent, but the world it has to survive in? Today, we're diving deep into the nature of AI environments.
And to get us started, think about this. We have AIs that can crush the best chess grandmasters on the planet, a game we think of as pure genius. But getting an AI to reliably drive a car through a city, that's still a monumental challenge. Why? It's not about raw power. It's all about the world each one has to face.
So here's how we're going to break it all down. First, we'll cover the basics, what we mean by an agent and its world. Then, we'll look at a super useful tool called PEAS. After that, we'll get into the real heart of it, the properties that define an environment. We'll use all that to solve our chess versus car puzzle, and wrap up with why this concept is so important.
All right, let's jump in. At its core, any AI system you can think of, no matter how simple or complicated, comes down to this one fundamental relationship. First, you've got your agent. This is your doer. It could be a physical robot, sure, but it could also be the software running a self-driving car or even your home smart thermostat. You know, it's the thing that's trying to get something done. And then you have the environment. And this is, well, literally everything else. Everything outside the agent. For that chess AI, the environment is just the board and the pieces. But for a car, the environment is insane. It's the roads, the other drivers, pedestrians, traffic signs, the weather, the whole shebang. And these two are locked in a constant loop. The agent perceives the world using its sensors, think cameras or GPS. Then it thinks about what it's seeing and decides what to do next. And finally, it acts using its actuators, things like a steering wheel or a robotic arm. That action changes the environment, and the whole cycle starts over, again and again. So, if you're building one of these things, how do you even begin to describe the problem? How do you map it all out so you can build a solution? Well, you start with a really simple but powerful acronym, PEAS. P is always step one. It's a checklist that forces you to define the entire task. P is for performance. What does winning look like? E is for environment. What world is it in? A is for actuators. What can it physically do? And S is for sensors. What can it see or hear? Let's use our self-driving car to make this real. The performance measure isn't just get there. It's about being safe, efficient, legal, and even making sure the ride is smooth. The environment is that crazy, unpredictable world of public roads. The actuators are all the car's controls. And the sensors are the cameras, the GPS, the sonar, all of its senses. See? Just by filling this out, the enormous challenge starts to take shape. Okay, here's where it gets really cool. It turns out we can describe and classify any environment using a few key properties. And it's these properties that tell us exactly how tough the job is going to be for our AI agent. First up, is the world fully or partially observable? In chess, it's fully observable. You can see the entire board, every piece, all at once. But driving a car? That's partially observable. Your sensors can't see around a blind corner or know if a pedestrian is about to step into the road. An agent that has to guess about the state of the world needs to be way, way smarter.
Next, is it deterministic or stochastic? A deterministic world is predictable. If you move a puzzle piece, you know exactly what will happen. But a stochastic world has randomness baked in. When a car's AI decides to change lanes, it can't know for sure what other drivers will do. Will they speed up? Will it suddenly start to pour rain? That uncertainty is a huge complication.
And this one is absolutely crucial. Is the environment static or dynamic? A static environment, like a crossword puzzle, will patiently wait for you. You can take all day to think. But a dynamic environment, it moves on without you. While a car's AI is thinking about what to do, the traffic light could change, or the car in front could slam on its brakes. You have to think and act in real time.
And there's more. Is it a single agent or is it multi-agent, where you have to predict and react to others? Is it discrete, with a limited number of moves like in chess, or continuous, with an infinite number of tiny adjustments like steering a wheel? Each of these properties adds another whole layer of difficulty.
Okay, so let's bring it all home. We've got the tools now. We can finally, definitively answer that question from the beginning. Why is chess a piece of cake for an AI, while driving is so ridiculously hard? When we apply this framework, the answer just snaps into focus. Just look at this breakdown. Chess is fully observable, deterministic, static, and discrete. It's a closed, predictable, turn-based world. The car is the polar opposite on almost every single measure. It's partially observable, stochastic, dynamic, and continuous. Every single one of these properties screams complexity. It isn't just a little harder, it's an exponentially harder problem to solve.
So what's the big takeaway here? Why does all this matter? It's because of one simple, powerful truth. The environment dictates everything.
The kind of world you're in directly determines the kind of intelligence you need to survive in it. If the world is simple, the agent can be simple. But if the world is complex, dynamic, uncertain, and full of other actors, then the agent has to be vastly more sophisticated to match. It needs to be able to plan, to remember, and to handle the unknown.
The source material for this explainer puts it beautifully. It says we should focus less on how we think the agent should act and more on what we want to see happen in the environment. Success isn't about the agent's behavior in a vacuum. It's about the outcome it creates in its world. The world is the ultimate test.
And that leads us to one last thought to chew on. If an agent is truly defined by its world, and we are building AIs to operate more and more in our world, a world that's increasingly complex, connected, and unpredictable, what kind of intelligence does that demand? And what does it mean for our future with these agents? Something to think about.